Okay, so today we're going to talk a little bit about what is a server. This is a question that a lot of people need to come across or sort of understand. What is a server doing? What's a server versus a typical computer? And why it's important for a lot of technical services. Anyone interested in getting into the tech industry eventually is going to have to work with servers and use servers. So this training is going to try to quickly address that, and also give you an example of what a server can be, for home and small medium offices. So we're going to define a server. We're going to go through a couple of examples of services provided. We're going to talk a little bit about server versus PC hardware. This is for a typical enterprise server. Um, to run server services, you don't necessarily need enterprise grade hardware, but we'll touch a little bit upon what the difference is, and which is useful in case you're coming across things like buying guides and so on and so forth. And then we're going to do a quick run through of using FreeNAS. FreeNAS is a storage server operating system. It's 100% open source, and we'll go through in more detail about what it is and why it's a good example of using a server, um, not only for home use but also could also be applied for small and medium businesses. So defining a server, Wikipedia, on the first page, if you just type in servers in Wikipedia, has a pretty good and very general description. It says in computing, a server is a computer program or a device that provides functionality for other programs or devices called clients. Clients being typically sort of a what would sometimes also be referred to as a terminal device, is a device where an actual user or person or a client is actually interacting with the services. And those services are services which are hosted on a server. So you can run through several applications, and because you know people are constantly redefining applications and they're constantly developing new applications, servers are essentially the computers or the PCs that are running in the back end in data centers, or could be um, in your closet if it's a home server. It could be something which is designed to be up and running, up and functioning, um, 24/7, and is acting as a backend to help catch and serve this type of data, which can then be accessible to multiple devices like phones, computers, PCs, uh, iPads, tablets, etc., so that people can then interact and enjoy using the services or viewing the content or what have you. So some very generic use cases. Probably one of the most popular servers use cases these days is a web server of some form. It could be a web server hosting a website. That website could be storing files. It could be showing you pictures. It could be running things like Google. A couple of very popular web server technologies or software available is one is Nginx and the other is Apache. If you're running these services on a uh, PC, notebook, tablet, or server, you're essentially running what is a hosting service, hosting websites, and that is in fact being a server. Other examples, email, that should be fairly obvious. Most popular in enterprise is probably Microsoft Exchange, although there are open source variants of that like PostFix. And then of course, there's cloud-based email servers like Gmail, which are just running on Google's proprietary software in their data centers. But the backend server side of it is still a server. You'll have file sharing, printer servers, which are becoming less and more out of fashion. They're not as important as they once were, and a lot of enterprise grade printers these days have probably a printer service sort of built into the printer itself. There's something which is get requests and queuing them up inside the printer. Um, Database workloads for sure, still extremely necessary, extremely critical for most businesses and SMBs. Either you're deploying it on site, on premise, or you're using it in the cloud, like with ERP software. Um, and then the database workloads could tie in with a lot of application specific workloads. So if you have an ERP software, or you even have something like a video editing software, oftentimes that software will include a database like PostgreSQL or MySQL or SQL Server to help run and store the information and the metadata that is generated by those applications. And then there's a special set of computing which uses servers quite a bit. It's called high performance computing. High performance computing is essentially the replacement of supercomputers. It's what people use to build out clusters. There's a technology called clustering, which lets you use multiple servers or multiple computers in tandem. Um, HPC, these supercomputers are used especially in the scientific community, but also have a lot of usage cases for things like simulations. And simulations could be of anything from, you know, IC chip design. It could also be uh, things like for oil and gas, like monitoring or modeling uh, based on a series of data, what you think the oil patterns or the geological makeup underneath the Earth looks like, and um, there's endless use cases for supercomputers, just like there's endless use cases for servers. As people continue to develop new software, new applications, new solutions, they need a back-end computing infrastructure to run all of this, and that's essentially what servers are designed to do. A 24 by 7, always available um, computer, which is then going to take in information and serve up information on demand. So some example of services. Yeah, this is a little bit of a repeat of what we just discussed, but I wanted to give a visual example of what the service is, or what how it looks in a when it's actually deployed. So you could have things like say FTP, NFS, Samba, SMB, AFP. Um, these are all file share services. Um, you have remote login like SSH, and you can see uh, a picture of it here in this screenshot. So this is a terminal from an session on FreeNAS. And you can actually see there's a service which is essentially a daemon, or something which is running in the back end. And this is true for all computers. It could be something as simple as a process which is just waiting to serve up information. It could be a process which is interacting with, say, like your graphics driver on your system. But on the server side, generally a process which is then serving up data and offering a service to make it available. We talked in the previous slide about web services, one of which is Nginx. FreeNAS uses the Nginx service, so you can actually see if you type service Nginx status in the terminal, you'll see that Nginx is running. And you can see, this is essentially to an IT administrator. This is how they view the status of the services and make sure that they're up and running, or that they need to restart the service Nginx restart. They can control and monitor, and from the operating system, this is essentially what it would look like. It's a service which is just running, and you can view the status by entering a terminal command. But you'll have a whole host of other types of services, networking tools like DNS, DHCP, email, which we just talked about. A couple of examples are shown here on the screen. Firewalls are critically important, not just for the servers themselves, but oftentimes on the enterprise, you may have dedicated firewalls. We talked about that in the networking video. Um, Hypervisor workloads, KVM, ESXi, Xen. Hypervisor workloads, you could sort of argue that that's not maybe a server service so much as a technology. A hypervisor, what it does is allows a computer, typically a server, because servers are generally a little bit more powerful, to run many operating systems, so that you can split out and sort of divvy up what services and what tools are running on specific virtual machines, or specific, what are sometimes called, known by the acronym of VM. I'll probably do a more in-depth video about virtualization and how exactly it works in a later video. But for now, just know that there's this technology which often gets deployed in tandem with servers, and what it does is essentially increase the usage rate of a server, so that when you're buying the server, you can actually split it down and make better use of it so it can run several different services and applications um, on a single system. And then, of course, you have an endless number of proprietary software which would make use of these servers and essentially offer, new interfaces, new ways of doing things, and new technologies and applications for hosting and serving up content. Um, for example, Google. Google runs on many servers, and they do that by distributing the workload, but essentially building in redundancy in the backend so that they have thousands and thousands of servers which can handle multiple requests. And they do this, using a lot of proprietary technology that they've developed and also a lot of open source technology to serve up their search engine and their other, web-based content. Talking a little bit about the hardware, um, I think a lot of people, particularly if you're watching this channel or viewing this blog, that you have a basic interest and understanding of computers and technology. But we're an enterprise grade server. This little image is supposed to be a server. Um, is maybe different than, say, a PC or a notebook or a laptop. Um, the emphasis is on the computing and not on the display or the graphics or the user interface. A lot of times servers, they don't even have a user interface outside of a terminal. So the terminal and a bunch of text is the UI. So from the display, there's essentially no display on most servers. They're just set up, they're running, they're fine, they're in the back end. And then you would interact with the server by either using an SSH session, remotely interacting, or you're just interacting with the service itself. So like if I open up google.com, I don't need the server to display google.com. I just need the server to provide the information from google.com, which then gets rendered and displayed on my PC or laptop. So the PC or notebook, it'll have, maybe a 12 to 17 inch screens. Have probably something like 19 to 30 inch or higher external monitors on desktop. The CPU, you'll have maybe 2 to maybe upwards of 12 cores in a high-end PC these days, whereas our server would have, maybe 2 to 64 cores per CPU. That's 64 cores is the latest AMD EPYC line of CPUs. Very expensive, very high end. And then they have options to have 1, 2, or even 4 CPUs, sometimes upwards of 8 CPUs on a single motherboard in a single system. So you can have, hundreds of cores and hundreds of computing threads available to you. And the reason they do this is because they not only can handle more requests and more host requests for specific high-end transactional applications and hosting maybe thousands of clients accessing this information at any given time, but they can also through virtualization run multiple operating systems. So they're doing double, triple, even um, you know dozens or you know dozens of virtual machines or something, all running on a same hardware footprint. So there's a reason why servers are built to be so powerful, and usually it comes down to computing density. Um, in the RAM, you'll probably have a very high-end desktop or laptop these days would probably have upwards of 32 gigs. For a specific workstation, you could probably even go up to hundreds of gigs of memory these days. But servers, some of the high-end machines, particularly like a 4-socket CPU, could have upwards of 3 terabytes of memory. That's more memory than the storage space of my hard drive. So they can get very, very powerful. And in terms of storage, they can also expand quite a bit more. So, on a desktop or a laptop, you'll maybe have like 1, 2 hard drives. A server could have, probably around 4, but then scale up to over 24 hard drives in, say, like a 4U, 4 rack unit size. It's a slightly thicker version of this device. And then they can also connect to external hard drive arrays, so you can store lots of hard drives, and hundreds of terabytes, and some systems can scale up to over a petabyte of raw storage. So they're depending on the purpose, they can be sort of purposely designed and purposely configured. Um, but essentially, you just get more and more and more of pretty much everything, um, compute, storage, memory. The only thing that servers really don't do better than, say, a PC is probably the graphics. And that's because they're not designed to be attached to a graphical interface. Um, in terms of the graphics remote management, we just discussed about that. Servers will often come with additional things like what's called IKVM. It's an interface so that you can access the server via the network. Um, a lot of servers will come with a proprietary port, which is built to a standard called IPMI. It says alert information for monitoring tools about the system status and the health of its components, and also um, allows users to remotely log in to the server and access, what the operating system might be running at that time. It's quite useful for certain usage cases, particularly if you're running, in a data center and you have hundreds or thousands of servers. You may need this because it's much easier to just type in, say, the IP address of the server and access it to see if there's anything that looks fishy or you need to make any changes to the server. You can do that over what's called the IKVM. That's not something you would need on a PC or a computer because it's designed, again, to be right in front of you all the time. So if there's anything you need to access, it's right there. Um, and then networking, typically Wi-Fi is not going to be on a server, but they do have higher bandwidths of Ethernet. So 10 gigabit Ethernet is becoming, the de facto standard, whereas on the PC notebook, you're probably running maybe 1 gigabit at this point. But they can also go higher to 25, even 100 gigabit Ethernet is available these days. There's other protocols that is used for storage called Fiber Channel. It's a protocol which would connect to a backend SAN device or a storage array network. And then for high performance computing, there's another network interface called InfiniBand, and InfiniBand is typically used just for clustering and the protocols that they use in those stacks. So a broad overview of the differences between, say, a PC and a server from a hardware standpoint. But again, the services that you run on a server do not necessarily have to be run on server grade hardware. So, and that's where we're going to talk about FreeNAS. So I'm going to bring up the FreeNAS in the terminal or in a separate window. So in FreeNAS, what it is a storage operating system. It's designed to be file share first, but it can also run other applications and other usage cases. So we're going to just log in and go through this. So in FreeNAS, when you first log in, you get a UI. You'll get an overview of the system, of the status. You can see things like, the memory usage, your storage pools. If you have multiple storage pools, you'll see multiple cards. You'll get alerts. Um, this is alerts because I have some replication tasks which are failing. And the reason they're failing is because I didn't actually turn on the other virtual machine running the replication target. So this is all expected, but if you had something set up and you weren't using FreeNAS or something just for testing, which is what I'm doing, then you would get immediate alerts about anything going on with the system. You can go in and manage users and groups. This is something very important on servers because oftentimes if you want to control who can log in and who can't log into a specific system, you want to set that up here in the users and groups. FreeNAS is built to be a network attached storage array. So it's called a NAS, hence FreeNAS. And the storage is very important to FreeNAS. It uses what's called the ZFS file system. It's a extremely robust file system where you can control RAID groups. RAID is a way of giving you additional redundancy, but also a way to pool multiple hard drives together to make one large storage volume. And also it has things like snapshots, which lets you better recover your data and make sure your data is intact. It can do remote replication, so you can back up the storage and the information on this FreeNAS to, say, another FreeNAS located somewhere else, or FreeNAS is provided by this company here, IX Systems. They also have enterprise-grade hardware called TrueNAS. FreeNAS and TrueNAS can work together. So if you ever want to upgrade or you have an enterprise use case, you can always upgrade from FreeNAS to TrueNAS. And you can do so many things with FreeNAS. It's really quite amazing. So going through here, what we'll start with is just the basic setup. We'll just create a storage pool, and we'll create a share, and then we'll start sharing files. So here I have one storage pool, and what we'll do is we'll add a second one, create a new pool. So when you're inside the create a new pool, you can give a name. And then FreeNAS will show you the available disks that you have. Now these are all virtual disks, and I'm just going to add all of them in. You could also split it out into multiple RAID groups, which can sometimes give you better performance. For now, because I just have a small number of disks, we're just going to do one single RAID group. Inside the RAID group, it'll give a recommended RAID config. Again, I know I didn't cover RAID in any of the information, but I'll try to put more links below in the blog so you have a better idea. But essentially, RAID Z, what this does is it's similar to traditional RAID, if any of you are familiar with that, like a RAID 5. It essentially allows me to use all three disks together, and if any one of these disks go down or any one of them fail, I still have access to the data. And it does it at the loss of one drive worth of capacity. So once I add all these together and I create this pool, we should see around 10 gigabytes, a little under 10 gigabytes of usable space. So we'll wait while the system creates it. Okay, collapse this. Pool 1, you'll see the storage 2. This is the pool 2 that we just created. Now what we're going to do here is we're going to add a data set. There's data sets and zvols. Zvols is what you use for block sharing. If you want to use iSCSI, what iSCSI lets you do is you can basically treat your FreeNAS storage as a hard drive, like on your system. So if you were to look at disks, if you were to mount an iSCSI target, you would be able to see a physical disk here, where that disk would actually be the remote hard drive pool on the FreeNAS located, off on somewhere else on your network. What we're going to do is we're going to add a data set, and we're going to attach it as a network storage share. So what the difference would be on your operating system is it wouldn't show up as a physical drive. What it's going to do is it's going to show up as a separate folder pool, and we're going to create that in just right now. So what we're doing is we're creating a file share. So I'm just calling it a file share. So this is going to be a data set in which we can store and then share it out to the network. Collapse this first pool. Then here you can add sub data sets. So you can split down from one data set. You can do several sub data sets. We're not going to do that right now for this example. You can also split it out as a zvol. It's very, very flexible in what you can do, and this is all through the power of ZFS. You can also edit the permissions. This is something which we're going to talk about in just a second. The way permissions work, I could probably show it real quick. These are what's known as Unix permissions or POSIX permissions. These are the permissions which would get applied and be used if you're using a say like an NFS data share, something which is really known to or used for both FreeBSD and Linux. What we're going to do is we're going to set this up as an SMB share, and I'm going to set it. Let me actually create one more data set. I'm going to go through a couple of examples. So when you go over to, when you want to share out this data set, you can go to sharing. And we'll pick this Windows Share SMB. SMB is a protocol which is supported on Windows. So if you're running a Windows 10 box or um, even earlier versions of Windows, you can connect to this share. But SMB is really flexible in the sense that Linux and Mac OS, so Apple computers, can also connect to an SMB share. So if you have a network where you have many different users connecting to the share using various devices, they can all connect using this. So quickly, we'll just add this. Go into this user group. Now in this data set, we just give the share itself a name. So I'll just call this maybe SMB share. And then this SMB share, this is just where I'm going to store my data on my FreeNAS. I could also call it FN share for FreeNAS share. And then you have this option here for Time Machine, which is the Mac OS backup and recovery software. You also have the ability to allow guest access. For now, we're going to click this, and we're not going to enable shadow copies. Shadow copies is a Windows backup scenario, so you have the ability to support both Mac OS backup and this VSS clients, or what is the virtual shadow copies, which Microsoft uses to back up and restore files. Essentially, what this would do with enable shadow copy is you enter snapshots on the FreeNAS, and then you can recover them directly from previous versions of those files within Windows. A little bit out of the scope of this video, but I'll include more information in the blog about where you can understand more about a lot of this backend technology. For now, we're just going to allow guest access. And we're going to configure this ACL. So the way guest access works and the way the permissions work is, though you enabled guest access in FreeNAS from the SMB settings, we didn't enable guest access to the data set. So remember when we looked at the permissions on the data set, there was the ability to anyone who was, regardless of whether the data set owner was set to the owner or a member of the same group or some other, or essentially guest, they had read access to all the files. They had execute access, so software could run even if the software wasn't owned by the same owner in that file structure, but they couldn't write any data. So what we're going to do is we're going to change this ACL. ACL is what's used in an SMB share. We're going to call this open. Now when it's open, you can see this access control list here. This essentially tells you the owner of the data set has full control. Members of the group of the data set also has full control. And everyone, or essentially the guests, have the ability to modify. So if they have the ability to modify, then they can read and write data. And we'll save this. Okay. Now, what we should do is also check in the Services tab just to make sure SMB is running. FreeNAS typically prompts you for this if it's the first time you've set it up, because this is an existing box. It's already been set up, and it, yes, is running. These are all the different services, again, talking about what servers do. These are all the services which are running natively on the FreeNAS. You can turn them on or off depending on what you need. So you have things like FTP, iSCSI, and we see the SMB service is also running. So we should be good to go. So now all we have to do is mount the file share. So going back to this Linux box, we'll type in at top. This process is similar to what you would do on Windows. So in Linux, we specify the share type as SMB. In Windows, you don't need to, because Windows only supports SMB. So you just type // and then the IP address. Of your FreeNAS, and then / the share name. We call it FN share. Now again, because this is Linux, we want to add that SMB at the top. open, and then because we set the ACL policy to open and we allowed guest access, we should be able to connect anonymously. Okay, so here we are inside the share, and we can create a folder. Okay, so that works. Let's see if we can save a file. Open up a text editor, and we'll type a we'll see if we can save it. Go over to this file share that we have over here that we just mounted, and we'll just save it. Give it a name, test.txt. Okay, so that worked. If we go over here and refresh this page, see that that's saved okay. We can also now go in, and if we wanted to, we could just copy files to the storage. It's essentially just like a local folder, something which we can access from our desktop and then save files to. So just open this in a new window. We got some pictures over here. We can save them over. It's copying the files over to the NAS. A little bit of a slow network. Okay, but here and now from the NAS, from this folder that we just mounted, we can open it up and actually see the pictures. So there you go. Now, one of the things that also makes FreeNAS really powerful, and in a lot of FreeNAS tutorials often doesn't get talked about too much, is it has a technology called jails right here. What the jails do is they allow you to set up customized services which also run on the FreeNAS. Okay, so you can actually install other services so long as the service is based on the operating system FreeBSD. I'm going to start one jail here just to show an example. And inside the jail, what it does is it locks down a section of the FreeNAS. FreeNAS is based on the FreeBSD operating system. And by nature, it's designed just to act as a storage. So the default services, the services that we just looked at in this screen, are all services which are just running directly on the FreeNAS, on the base OS. And they're set up and they work, fantastically. But if I wanted to add other services, I can add a jail. And if I add the jail, I can set up, essentially my own little server world. It works almost like a virtual machine. You can also install virtual machines, by the way. But inside the jail, it uses a little bit less resources than, say, installing an entirely new virtual machine. A little bit easier to set up so long as you're familiar with the command line. And to make it even easier, FreeNAS has a lot of sort of pre-baked jails, which they call plugins. And these pre-baked jails, these plugins, if you install any of them, they have different services like a secret backup, backup PC, Iconic for setting up a media account management platform, MineOS, etc. They have a whole bunch of software which you can just pick from and just install it like a package. And if you're familiar at all with other NAS systems out there like QNAP or Synology, they also have their own sort of package or account store, and FreeNAS is no different. They have these pre-baked packages, and when you install the package, it basically installs the packages and then sets up its own jail, just like what we were looking at here. And then what we can do in this, you can see like here we have an Iconic Storage Gateway or Nextcloud, backup PC. These are all plugins. This FAMP that I have, or is essentially set up to be a web server. And if we go in here, we can actually go in and access the jail. I just started it, and click on the shell. And here we are. So inside the jail, it's basically your own little virtual world. You can do lots of things. One of the most interesting things is it also has its own network. So if I type the command ifconfig, remember this from the networking section, we can see here that the IP address of this jail is different from the IP address of the FreeNAS, but yet the jail is running on top of the FreeNAS. So it has its own VLAN, it has its own IP address, and if we go to that IP, because I set this up to act as a web server, we should be able to see a web page. So let's just double check that. 192.168.123.1.254. Yeah. And then here you can see this is actually running a web page, and this web page is running locally on top of the FreeNAS. So the FreeNAS is acting not only as my storage server, but in a jail, in a secure environment, it's also hosting a website. So you can really expand upon the capabilities of FreeNAS and make it work almost any way you want it to. And what's best about it is not only does it do all of this from a functionality standpoint, it's also a really easy way to set up, start using a server operating system so that you can get started and sort of understand more about how servers work and how do I interact with a device that's not just my own PC. It's a PC plus a network. So again, this is really, when we talk about the building blocks of IT technology, FreeNAS is a good first step to understanding what backend technology would be: managing storage, managing files, managing services. All of these things are what make up and create, you know, servers and what people do, in the IT backend. And you can expound upon this. You can, add all sorts of things in the shell. If you do a package search, you can search for all sorts of files and programs and things. So you could search for it, say Nginx if you wanted to, um, and then the jail will go off and search for the available packages. I think there's a lot for Nginx. There you go. So there's all sorts of packages and things. So you can just modify, install, and just use the jail essentially as a virtual machine, as like its own little operating system. And it's locked down and it working as a subset of the FreeNAS box. So again, just wanted to do a bit of an overview, explain what servers are, what the goal of servers are, provide services that, support additional applications. And then using FreeNAS, we ran through an example of how to get started with FreeNAS, but also how to get started understanding, exactly what a server can do for you, maybe on your home network or also in a small or medium business capacity. So thank you very much.